In this video, I'll show you how to build site search with LLM capabilities. Users will be able to ask about the site's content in natural language and get an actual response from an LLM in natural language using results from your website. This will happen with multiple software packages. I will not be using a ready-made solution specifically for that reason. We'll build it with some open source software and packages. It's important to mention that I will also show you how to build a fully local running free version using an Ollama model running on a local server. This means you can run this entire infrastructure and software for free. We'll start by crawling the website with Chroma for AI to get its content in Markdown files which are friendly for large language models and don't waste a lot of tokens. After that, we'll chunk the Markdown files to pieces and feed them, embed them in a vector database so that we can query them with the user prompt and get results that have relevant meaning to the question asked by the user. Finally, we'll build a RESTful API that uses the OpenAI client, augments the user prompt with relevant context from the documents in the vector database, and get a response from an OpenAI compatible API. Without further ado, let's jump in and crawl the data. Here's the website I'm going to be using. This is the NASA missions website, and we have some interesting content here with interesting facts about different NASA missions. There are also plenty of pages, over 700. In fact, I will not crawl all of them probably, because we're doing a proof of concept and 30 pages will be enough to demonstrate how to implement that and be able to ask different questions about missions. Now, to actually crawl this, we'll use Chroma for AI. Towards the end of this video, or at some point, you can use the timestamps to see, I'll mention a couple of other alternatives, as you might not need to crawl your own website if you already have the data available. You will probably be building this search for your own site. And in that case, crawling might not be a necessary step. You might just need to convert your pages to an LLM-friendly format like Markdown, or you could feed them as HTML, raw HTML. The downside to that is it might be a little bit more tokens because it contains the necessary HTML formatting data. And Markdown is really perfect because it retains the structure of the content without wasting too many tokens. And ideally, we want to optimize the token size for LLM performance and costs if you're running this through the OpenAI API or any paid API for that matter. But in this case, I am building a search for a site that I do not own. This is the NASA missions website, so I need to crawl. And Chroma for AI is a Python software that crawls websites and outputs their content in Markdown that is LLM friendly. It also has a lot of other functionalities. Today we're going to be using a very basic subset of its functions. It's very sophisticated, kind of a sophisticated crawler that you can use for many purposes. But to start, you just have to install it. I will create a new project for that. Let me open my terminal. I'll even make it full screen right here. And increase the font size a bit so that it's clear. So I'll go to my developer folder and I'll create a directory called crawl for now. And here we'll do all the crawling. I will install Chroma for AI with pip. I already have it, so it's probably already the latest version. And we need to run post-installation setup, which will probably just install browsers. Yes, Playwright browsers and a database in it. And finally, we can verify our install. Let me zoom in with Chroma for AI Doctor. Let's run that. It should tell us that everything is working correctly. I guess it's running a test crawl, probably. Yeah. All right. And at that point, we are ready to actually implement a web crawl with Python. And let's do that first. Let's run their sample scraping MVC news. I will open this in new Vim. Actually, no, let me quit new Vim. I'll start a tmux session because I need multiple terminals. I'll open this in new Vim and create a main.python file, and paste that here. So it will scrape NBC News, the business section, and print the markdown from the results. Let's try to run that first. With Python, of course, you need Python at least. This is the only project, the only software package we'll be using Python for. I will build the rest in Node.js as I'm more comfortable with TypeScript. And I am not a big fan of Python for most cases. But of course, this is not specific to any programming language. Any of the software packages I'm mentioning today can be implemented in many different technologies. Of course, Grow4AI is a Python package. You would need to use a different crawler. I'll be using the OpenAI Node.js package, but you can achieve the same things with really any programming language in any ecosystem. Now, as we can see, the scrape completed successfully, and we get the NBC News page in this markdown format, as you can see. And that's great for LLMs because we're not wasting tokens for HTML tags that are just useless for an LLM. They're useful for browsers where they are rendering actual things. Now, let's clear that and go back to the Python script. We need to do some config. And for that, let's go to the Grow4AI documentation. First of all, let's check out the NASA missions page. We need to crawl in depth. Ideally, we would want to crawl all of these missions from this page onward, maybe at least page 1 of the missions, and maybe crawl the relevant, the related missions here. If we have others, we don't have related missions. So to do so, we will need to do a deeper crawl. And Grow4AI has that capability, of course. Deep crawling section. There we go. Quick example. And we can actually copy this example because we're still not really haven't written anything serious. And here we just configure it with this config, which is crawler run config. And we're doing a breadth first search crawl strategy, which is great actually. And depth of 2 is probably just fine. We could go to a depth of 3. We should not include external sources. This is external links, I'm guessing. Let me see for matches. Yeah, stay within the same domain. Sorry, I lost that. Oh no, I didn't. It just has some broken anchor links. That's terrible, actually. Okay, we have max pages, and I'll do that as well. I want a max of 40 pages. That's enough for now. I don't know if Python supports the comma last syntax, so let's keep it clean for now. What else do we have? We need to also filter results a little bit. Let me see. In simple crawling, we need filters, some kind of filters, because here, if we start crawling everything, there are many other links in the navigation, in the footer. We don't want to crawl everything. We want a very simple structure. This is all under nasa.gov/missions, and all of the missions are under /mission/the mission name. So a very simple case for crawling. We need all of the links under mission, everything. And that's done with filters here. Let me just find them. Let me use the search right here. So here we're talking about content filtering, but I'm more interested in different kinds of filters. I probably should look at deep crawling. Okay, filtering content with filter chains. Great. So that's what we need. A basic URL filter is just fine for our needs. Let's copy it. I'll also zoom that a bit more. We need to import it. As you can see, Chroma AI is quite modular. So we are making a URL filter. Let's put that in the main function. Why not? I'll delete that line. Indent. And we're using growth patterns here. So basically, we care about anything that has missions or mission. And I will do just that. Missions or singular mission. That should be fine. All right. And we need to actually incorporate that filter in the crawler config. So let's see how to do that. Filter chain. That is actually terrible. I hope they fix that soon. If you click really anywhere on this page, it will just scroll you to somewhere arbitrary at the top. I guess there's a broken anchor or something, but it's extremely annoying. Let me go to filter chains. At least I believe there's something broken like this. I hope it's not my browser. Yeah, let's copy the example and I'll extract it because I don't want to mess too much with the documentation. There we go. That's in the deep crawl strategy, of course. That is a part of the deep crawl in reality because we're filtering the discovered URLs. Okay, let's go up, 10 up, and delete. I'll insert some space here. So now we have a filter chain. The URLs will actually crawl are filtered. We also need to actually not crawl the entire pages because we have this navigation that is it's unnecessary and it's just clutter in the content. We don't want it. We want the main content really. And thankfully, I think the main content here is within a main tag. Yeah, we have a main tag that excludes the navigation and footer, but we could also use something even more specific. I guess a main tag is fine. So Chroma AI had the ability to actually select specific content. And that we can find right here, content selection. All right, we can use a CSS selector. That's one thing. And that is where in the crawler run config, sorry, it's a mouthful. And here we can select main, the main tag. That should be enough. We also have the ability to, I think, exclude elements, excluded tags. Yeah, and that's also a very good idea. In most cases, that would be probably the best solution if you don't want to do specific content, but you are just extracting content from a general site. You don't want the nav, the header, the footer, or any forms because they don't usually contain meaningful information in any form, and they shouldn't. They should be navigational elements primarily. And I'm pretty confident in that, except I don't just want main. I think on this first page, the content was not in a main tag. Yeah, it's not. And we need it as well to actually explore the content to find these links at the first place. And I think we can just target this ID, mission results container as well. This is a CSS selector, so I can do that. So yeah, using these filters and selectors, you can basically tailor this crawl to your website and select specific containers of content like the main tag or an article tag, whatever it is. You can do multiple crawls. You can crawl the blog section with a specific selector or another subset of pages with another selector. And as I mentioned, in most cases, you don't even need to crawl your own website. You can just export relevant data and convert it to Markdown. HTML to Markdown conversion is relatively straightforward, and there are many packages available in all programming languages. So we have the crawler config. Of course, we need to run it at some page, starting from this page, now submissions. So let's do that. And instead of printing the results, we would want to save them in files. And we'll do just that. I guess we don't need the documentation anymore, really. So I can actually ask Avante, save the results to Markdown files. Save the results Markdown content. And it should be able to do that successfully. Okay. Let's see what's happening. Here we have ID results in results, but the first three, I don't know why. I don't want the first three, I want all of them. Result ID +1, that is just fine. I would say, yeah, that's perfectly fine. Let's save them here. File name, we open it in write mode, UTF-8 is fine. And we save result content. We need to save result markdown. File name, URL, metadata. I think that's pretty good. And keep in mind, we will save the results, but we also need to save the metadata. And that is necessary if we want traceability. At the end, we will build an API that's asking questions, and it will retrieve some chunks from different pages. And ideally, at the end of the answer, we would want to show the actual pages and links to them for the full content. And to preserve that traceability, we need to reference each chunk in the vector database with some URL. And we have to incorporate that here. And as I'm going to be saying the results in different Markdown files, there's not really a very good way to save metadata there or a URL as metadata. I will make a separate metadata JSON file that saves just the URLs, and they will be by ID, of course. And let's actually prompt Avante to do that. But first, let's test this functionality, and then we'll do the rest. Now we have just a main.py file. So let's run it and see what errors we have and if it runs correctly at this stage. So it seems to scrape, which is very good. Our filter is working correctly, so you get different missions. That's awesome. And each step fetches the site, scrapes it, and completes. It's completes the process. So let's wait for this. And oh, actually, it saved the result a lot more quick. It's quicker than I expected. And we have the results here. Let's open this in Finder and check them out. This is in Developer Crawl. And these are the results. Let me just go to a different desktop where I don't have OBS running. And this is the main file. This is one of the Markdown files. And we have 35 pages, which is all good. Now, of course, I don't need to open them in Xcode. I wanted to check out the results in Finder. Not sure why, but I can check them out here as well. I am in new Vim, so I can check out result 10, for example. And that's one of the missions, Able 5A Pioneer. Yeah, we have the content, headings. We have some other we have tables here, and all the content in Markdown. Yeah, we have some links as well, but that is perfectly fine. Okay, now we would also need an actual, as I mentioned, metadata file. We have each result with an ID. Ideally, we should be able to also identify the URL with the same ID. And let's do that. I want to prompt Avante, save a metadata JSON file where you save each URL where you save an array of page ID and its respective URL for all pages in a single file. I hope that will be enough so that the LLM will understand me. It seems like it did. Metadata is JSON, an array. We append ID, URL, and here, of course, we have the actual save of the metadata. So let's run the crawl again so that we can generate the metadata as well. And I'll speed that up or cut it so that we don't wait for the crawl. Okay, let's check if the metadata file was saved. Absolutely. And this is what we wanted, ID to actual URL. And that's great. Okay, so this is the data we need. Ideally, this is the actual data you would need to get in order to build a RAG site search. You would need the page content, ideally in an LLM-friendly format that doesn't waste tokens like Markdown, but HTML would work too. Really, any textual format would work. And some metadata to relate the textual content to the actual URL. Because we'll chunk this. We won't feed these files as a whole, and the large language model will not be able to reference where they came from. We'll feed them as little chunks for better precision and so that we don't waste tokens. And it's important if you want to actually have a search that outputs natural language plus some pages on your site where that data comes from, to actually have the metadata for reference. If you don't, you would just get a natural language response without any reference, which might be useful in some cases. All right, now we have the data. The second step is to chunk it and feed it to an actual vector database. And here we have a couple of options. What I'll show you today is using Chroma. Chroma is one vector database choice. There are many solutions. There are cloud solutions, solutions with less code, more code, harder ones. You can use Postgres, Vector. Chroma is an easy and open source solution that contains everything necessary to embed data in a vector database without doing anything to start. And you can scale it up or use it in a cloud instance too. But today we'll run it locally, free, and use the default embeddings model. Now, here there are a couple of opportunities to improve quality. The quality of the output of the vector database will depend on a couple of things. First of all, let's mention what this will do. We get textual content. We split it to small chunks. We generate vector embeddings, which are representations, just a bunch of numbers in vector space that represent the meaning of the textual content we embed in the vector database. And this whole thing allows us to retrieve data, query that vector database with a natural language question, and the vector database will retrieve the most relevant documents to that question in terms of meaning. They don't need, it will not query them in the natural sense with fuzzy search or something like that. They can not contain even one keyword in common, the question and data. But if there's meaning in common, you will receive the documents back, which is great because that's exactly what we want. We want the most relevant context to our question. And that is tricky. There are many solutions to that. Vector databases are not something soft or easy, or there's no best solution. You have a lot of opportunity here to optimize, to tweak, and to make your RAG, essentially, this is retrieval augmented generation, perform better by making the vector database process more optimized. And you can do so in a couple of places. The first one is the data, the quality of the data, and what size of chunks you feed to the model. And the other very important place is the embeddings model. We use a model to generate the vectors. And that model is very important because it essentially embeds the meaning. It generates the meaning we use to later query the database. So in general, I would say you will probably find that the embeddings model and the quality of the data are much more important than the database engine. But of course, sometimes the database engine can also play a role. Everything is important, but these two things, the chunking, the quality of the data, and the third thing, which is the embeddings model, are quite important for the quality of the data. And you can play with it a lot to improve the results. For this example, thankfully, Chroma provides a default embeddings model that is free. We can chunk the data with a different package in Node.js, so it will be very easy to start. And that's great. And actually the results, even though it's easy to start, are not that bad. The default config is quite good, but it depends on your goals, of course, and your data. And now let's go to the getting started guide. Chroma is quite easy to install. It's a Python package, but you can also use Docker. Here, if you go to the TypeScript, it has a TypeScript client, which is great. It shows us, I think, the Docker container. Yeah, the Docker container instructions. And I will use the Docker instance, actually. I will not use Docker. Also, I will just go with Apple containers because I'm using Mac OS right now. Really, Docker, Podman, Apple containers, everything will be able to run Chroma. So whatever container engine you have, it's fine. Let me just close my terminal session so that we start clean. I will leave the crawl package for now. Let's create another directory and we'll call it rack search. It's just the name I chose right now. We won't do anything in the folder. First, we'll install Chroma. So let me do container list. I need to start container system start on a Mac. You can follow the similar Docker syntax or just copy the Docker commands from the Chroma getting started guide. I believe there was a guide here. Yeah, Chroma in a Docker container. And here you have the Docker run command. It's quite straightforward. You just expose a port and bind the volume for data. Now, let me go back to the getting started guide. I have the Chroma image pulled, so this should be fairly straightforward. Let me just move these desktops a bit so that it's more convenient for me to navigate. I started the container system. I'll list all containers because I should have a Chroma running. Yeah, I'll remove the previous container by its ID. I, of course, tested this multiple times before making the video. Not Chroma remove, but container remove. I have a typo. Okay, let's list all containers. And now let's list the images. Here it is, the image, ChromaDB Chroma. You can pull it with container images pull ChromaDB Chroma. And of course, you can do a similar thing in Docker, just Docker pull ChromaDB Chroma. And I can now run a container with that image. And the container starts. But let's remove it real quick. I'll first stop the container, remove it. Let me list now. Okay, let's recreate it, but this time in detached mode. ChromaDB Chroma, so that it doesn't take a session here. And if I container list, it should be running. And we have in Apple containers, it has a specific IP because it's running in its own VM, which will be the IP we'll be using to access Chroma on port 8000. And for now, I can leave that be. Now let's see the Chroma client. We'll be using TypeScript. So let's do npm init. Just a very basic project. I'll make a source directory. This will eventually become a RESTful API. So I'll install TSX as a dev dependency to just run TypeScript. This will be one of the first things. We just want to run TypeScript files easily. I will create an index.ts file in source, and let me open that in new Vim now. My start command will be tsx. Let me remove that. Okay. And that is enough for now. We don't need much more. Let's go to the index.ts file and just print something to test if our build and run is working correctly. Let's go to rack search, npm run start, and we get our hello world. So we have a TypeScript application. Now next step is to install the Chroma client and the Chroma default embed package. I'll use npm or pnpm. Let's use npm. I'll go to the terminal session and install ChromaDB and ChromaDB default embed. Okay, now that we have the two packages, we can go back to the guide and we can see, of course, that we have to install the client. We can run the client now. But for that, let's paste. I will also create a main function. Okay. I like to write a main function. It will need to be async at some point and to run it. I'll move this new client down. Okay. And now we have a new Chroma client. And some of the first, here's how you use Chroma. It's quite intuitive. You create a collection, which is like a database table. Okay. That's very interesting. Let me quit because I have an issue with my bindings. Unfortunately, I lost. Okay. Let me just copy that again. I lost my code for a second. Okay, everything is written now, so it should be fine. Again, an async main function. Not much was lost. All right. And let's move that again. Now, as I mentioned, it's quite simple to use Chroma. We create a collection, which is like a database table right here. It should have a name to identify it. Let's create a sample collection now to just see how it works first. Then we can add to that collection like this. Textual documents. This is a document about pineapples. This is about oranges. And this is the document content right now. And they have their unique IDs, of course. They can also have metadata, which is helpful. And after that, we can query for results, which is step 3. And you can see the meaning here because we're querying. This is a query document about Hawaii. So there's nothing about Hawaii in the main documents, but some of these fruits are related to Hawaii. And we should get the distances in terms of meaning to this sentence. We have a syntax error. String is not assignable to type string array. So there's an error in the documentation, apparently, or it's an old document or documentation. Let's see. Will that fix it? It does. Let me also remove these comments as they are quite unnecessary. And the results is the number of results we want to get. No, we have only 2 documents, so let's get both of them and see the distances. And now if I run this, and let's see, Chroma core default embed. So we need to install that package as well. The documentation did not mention it. This is the default embedding function. And now let's run it again. This time it should work. We have a Chroma connection error. Of course, we are running Chroma, not on the local host basically, but in on a different IP in a container. So we have to set the address. And let's see how to do that. We have to go to client, I think, to see the actual documentation. But let me find the client docs. They were somewhere in here. This is about collections, the client. Okay, host. Well, it seems like it's host, although the documentation is not that rich. Maybe the documentation in npm will be better. Let me see. Chroma client, path. Okay, this is better. And here we get the path, which will just be that IP. Okay. The IP from the container. In your case, depending on how you run this, it might be localhost with Docker. It will be probably your local IP and localhost at a different port, depending on how you map it. Or the same port. If you map it to 8000 localhost, you won't need to even configure that. And now I should be able to run this finally. Oh, path is deprecated. Use SSL host and port instead. So let's use host. Then I believe we have SSL as a separate argument. Host and port. Here we need a comma, of course. And that should be the necessary configuration. Okay, the resource already exists. Let's name it something else. Let's name it fruits. So we have another error. Let's see what that is. Okay, I needed to reinstall Node modules in order to fix this native compilation error. Now I just removed Node modules folder and run npm install. And that fixed this runtime error, but it took some time to troubleshoot it and I did it off camera. And now if we run it again, we'll get the error that this collection is created because we are able to create the collection, but then the adding documents to the collection and generating embeddings failed. And we don't need to create a collection every time. We can say get or create collection. And now we can run with npm run start. And that would add the documents to the vector database. And then run our query right here. Let me show you while we're doing that. We add the documents and then we run a query that says this is a query document about Hawaii. And this is the result we get from the vector database. This is the query result. We get the documents, both of them in this case, because we want two. And a query about pineapple is closer in meaning. This document about pineapples is closer in meaning to Hawaii and the query about Hawaii. And these are the distances. The closer something is, the smaller the number will be. And in this case, we have distances, documents, and their IDs and metadata. And that's great. That's exactly the kind of functionality we need. Of course, you can control the number of results. Let me just comment out the adding of the collections because we don't need to add the documents every time. as I'm making another query, we already have the documents in the database. So I can now just run it. It will be faster. We don't add embeddings. And I just get a single document, which is the more relevant one about pineapples. Now, let's do this with the site data. Of course, we have the files right here in different files and their metadata. But we need to embed them and chunk them. And to do that, let me show you. I will use a chunking library. I was actually speaking with an agent about that. Let me just see what the recommendation was, because I like that chunking library. It was this right here, LongChain text splitter. I was just using the AI to research different chunking methods, and that one seems to work quite well, and it's quite simple. And of course, it's not exactly LongChain text splitter. The package is text splitters. So let's install it in the same repository. I'll paste that. And Quout's actual syntaxes was absolutely correct. We define a new, we use the recursive text character text splitter class, and we define a new class here for splitter and define chunk size and overlap. So how chunking works with AI and RAG is, people found out that if you have chunks that are smaller, the RAG can be more precise with a vector database and work better. On the other hand, if you overlap content a bit, meaning each chunk contains a little bit of content from the next chunk and the next chunk contains a little bit from the previous chunk, the results were better. So we have overlap and size. And these two parameters, as I mentioned, besides improving the quality of the data, which you can do simply by adjusting the crawl or how you just convert the site data to markdown that is friendly for the LLM and just inspecting the data yourself. The other thing you can do to improve the quality of the search is to play with these parameters, chunk size and chunk overlap. And there's no perfect number here because it depends on the content, depending on how long your sentences are, what the nature of the content is. If you're doing a technical documentation or a site about fiction, this will be different. And the only way to find out what works best is first if you inspect the chunk sizes and just think about it from a human perspective. Do the chunks make sense? And you can just adjust numbers and test end-to-end the end solution and see what yields better results with LLMs. But this is how you generate chunks. Just generate the splitter and split text, and that just generates a bunch of an array, basically, of strings, which you can then embed. And this example is great because it also shows how to add metadata to the collection, which is quite simple, admittedly. But we'll do that right now. So we installed LongChain's text splitters. I will create a new collection, which I'll call NASA missions. And I will comment out collection add for now. Actually, just remove it completely. I don't need it. I also will comment out results for now. I will query for results later to test. Now we want to create the collection and feed the data. And to do that, we also need the files. So I'll copy them and the metadata right here to the other project, which is RAG search. I have some file here, which is unnecessary, of course. And I will create a folder here called data, and I'll just paste these files here. Of course, this is proof of concept. I'm moving files manually through the file system. In a production environment, you would have automation for that naturally. Now, here, we need to write a couple of fs functions to get these files. And that's quite simple. In fact, let me just not bother and prompt Avanti. Sorry, I'm getting, maybe that's wrong. Oh, okay, good. So retrieve all MD files and their contents in an array from the project root data folder. Okay, that should be fine. Let's see what it will spit out. It should be good enough to just avoid writing some boilerplate. Didn't generate anything. Okay, let's do it. We need a file system Node.js package. And in fact, why did I move it? No need. Okay, quote. I could speed this up a bit by using the function from my proof of concept I did before. Let me see. I have this read files function, which I can use just to avoid writing repetitive code. Okay, here we have a simple function that uses read dir sync and read file sync to just get all files from a directory and read them in UTF-8. Now, this is not exactly perfect. Let's edit it. Only read markdown files. We'll be able to edit that. Okay, that is good enough. And here we can use that function before even creating the collection, or it doesn't really matter. I can just say read files. Let's see files 0. If we have the content. Let me clear the terminal and to run the program. What do we have? No such file or directory. Yeah, of course. The directory is data. And here we go. We have the file content. And we should have, let's see, files length. 35 files. Okay, this is correct, I would presume. Let's check. Yeah, exactly 35. And the metadata. Metadata is super easy to get. We can even import it at the top. It's perfectly fine. And just return it. So what's going on here? Used before its declaration. I have a typo here somewhere. Oh, this is called just like the function. It shouldn't be. It should be metadata. And let's just log it. Just to be sure everything is working as expected. So far, just loading a couple of files. Really nothing special. Now, ideally we should get the file ID as well. So I would say, let's not return this filters and then maps. So let's return the content and ID with, we can split. In this case, the ID is in the file name. That's not the best solution, admittedly. But it's simple enough for this case, of course. Let me just convert this to a comma. What else? Here we return an object and we return that at the end. So here we return a string array. We should return a, how do we call it? Page file. And let's define a type, page file, which will have ID, string. We can convert it to number because it should be an integer. Why not? And content, which will be string. Okay, let's see now. ID number content string is not assignable to type of page file. And why is that? ID is string here. That should be fine. Let's again walk files 0 to make sure we're getting the ID. Okay. And we are. ID and content. That's really all we need. And we need the ID to just relate it to its metadata. You can figure out other solutions as well. Really, you could save the results as JSON in the Python file. That would be even better, probably, than this. And having a single metadata file, you could save JSON that is similar to what we create right here, which has the ID and the markdown content within it, so that you can have some metadata. Or use an entirely different format. It's up to you. We're working with text files here. But this is sufficient enough for such a demo. The point is not really how you load the files. The point is the entire architecture and how we interact with the vector database and create this retrieval, augmented generation, and search. We will improve the architecture a bit because right now we're working in a single file, but soon we'll move away from that. Let's now do the retrieval. And to do so, we need to chunk the files. And as I mentioned, I will use this approach right here. I installed OneChain's text splitter. I can now just import it. So quote was wrong here. It's OneChain text splitters. I want single quotes, of course. Let's move that up. Okay. And the API usage it recommended is absolutely correct in this case. So let's copy that and move my desktop to the left so that it's more convenient. We have the files, we have the metadata, and right here we split it. Let me copy again and paste. Okay. So we need to split each and every single file. And to do that, we will whoop, basically. There we go. So let's split each file. I will go with the default. We don't need to define the splitter for each file, of course. We don't need to define the splitter for each file, naturally, because we don't need different settings. I will keep the default 1000 chunk size and 200 text over chunk over WAP, because it works okay for this kind of content. But as I mentioned, you should adjust these based on your content type. And now we just chunk the document. In this case, we will chunk file content. And this now is an array of chunks, an array of strings. And let's add them to the collection. We can do that here in the whoop. Yeah, one more. Just the documents will be chunks, just like we did before with pineapples, oranges, etc. The metadata, well, we can do something else. Metadata for each chunk. We need the chunk index. We don't need chunks, so we can do underscore page ID. That's important. Let's have URL here. And here we will retrieve metadata, file ID, URL. That's how we relate the chunk. Chunk index is fine. Source name, don't really need that part. IDs, just that I don't even need the chunk ID. I'll just do file ID, chunk index. That's fine. This is just the ID in Chroma. Like in any database, each file has an ID. Each collection, each chunk, sorry, or item has a unique ID, and this is a unique ID of my chunk. And this will insert to the collection the content in different chunks. Now, I'll do that once. I will not query for results. Notice, you will not run this every time because you will clutter your database with a lot of files. So you should have a seeding script, a seeding endpoint in most cases, which you can hook to some sort of a webhook when someone publishes a new page on your site, or you can run it periodically to update the data, because here we are working with a snapshot of the site. And the nature of the vector database is such that we need to duplicate the content in a different format to have meaning. And you have to invent a workflow based on the content management you use, the way you host your site and update your site. There's no one solution for all here. But at its core, you would need to execute code like this that splits that data, which is the pages, and inserts it to a vector database in chunks with metadata at some point. The most common ways to do that is with a webhook on page submission, when you generate cache, when you cache pages, or periodically, weekly, monthly, whatever that period is. If you have some archive or documentation that doesn't get updated frequently for an old project, you can do it once, I guess, every few years, only if you have new data. So this won't run all the time. And for that purpose, let's already extract it to a separate, I guess, function. Yeah, I'll call it seed data. And I will pass collection page files. Let's first create just a normal function and copy the necessary items here. Metadata, splitter, and this whoop. There we go. I'm doing this because I want to point you in the actual direction for the architecture, at least some direction. Now, collection is any right now. Let's see if we can fix that. Can you set the type of collection to the correct Chroma DB collection type? Let's see if the model will be able to do that. Chroma DB collection. Okay, so we can import that type. Let's see if we have it. Great. Single quotes. We'll see if it's valid. It might be just a hallucination, but in most cases, it can infer TypeScript types without me looking through the documentation. Okay, it seems to work. And now this function can pretty much see the data on its own. It accesses this function. Does it need any other dependencies from main? Not really. So I can just say seed data and pass the collection. Okay, let's add a console work here saying, yeah, seeded X amount of files into the collection. So you can see it works and run our software again. It will take time, and there are a couple of files and we need to embed them with the model. So I'll speed up the video here. Okay, so I got an error. I have a mistake here. I query metadata by file ID. In reality, we have to do metadata find metadata item equals file ID. And now we can get the URL. And metadata item will be, I can define that type at the top to have a cleaner syntax. Yeah, ID number, URL string, that's metadata item, basically. Let me see, is that correct now? Should be. Metadata item. Yeah, let's do that. Okay, let's now I'll run npm install again because I removed my dependencies because I had this compilation error again. Let's now run again and I will speed up the video again to the results. Okay, that is quite great. We see the 35 files into the collection, so it worked correctly. Now, I can comment this function right here, and I can query my collection of NASA missions. Let's try that. To do so, let's see what query I can do. I'll go back to the NASA missions website. Let me close these documentations and look for something interesting. 3D tissue chips is the first mission. Tissue, let's biomedical. Let's see. I'll ask something like, what can I use to heal my wounds? It should be related in meaning, although it's silly. And there we go. We currently want only one chunk, and that's how big of a chunk we have. If I do n results 10, we'll get a longer results and more chunks. And it's still, tissue chips can be chronic exposures, medicine, article, longevity tissue chips from biomedical research. So it's working correctly, multi-organ repair. We have related data. If I ask something like, what was the first spacecraft mission to the moon? Spacecraft mission, yeah, to the moon. Yeah, let's do that. Let me just run. And we have a couple of chunks. And if we go to the first one, which is the more closely related one, was the first ever launch to the moon. Pioneer 0, also known as Able 1. And we have a couple of these chunks here that we can later feed to the model. We'll, of course, feed something like 5, maybe. It depends. So you can also adjust that part. It's quite important. How long of a context you give it. Because first of all, every language model has a context limit. If you're using something like Gemini 2.5 or some of the larger context models, you can feed quite a lot of context to it. But also keep in mind that increasing the amount of context in many cases decreases the quality of the output. It depends though. If the model doesn't have enough context to answer your question, of course, the output won't have sufficient quality. We're talking here about providing the best context in terms of meaning with the shortest possible amount of tokens. That's the game, really. So you want quality data, the least amount of tokens, but quality meaning as well. Substance, which it can use to answer your question correctly and with sufficient meaning, ideally. But this is great. We have a collection of NASA missions, which we can query. We have a way to control a chunked vector database, and we can ask it questions and it returns results that are relevant to our prompt. In this case, here we'll feed the actual user prompt to get the most relevant documents to his question. So to actually continue, let's put this in a little bit of an order. I will organize this a bit because right now it's terrible, of course. Let's go to the terminal session. We'll create a couple of folders. Right now we have a source folder and a single index.ts file. I'll make a utils there or helpers folder. I'll make a models folder for the model. And let's start with that for now. So utilities will be read files and vault metadata. I even copy them immediately. I will go to, let me see, where will I go? To helpers, create a utils.ts file and paste them right here. I will export both functions from here. And we'll, of course, need to update the import here. Okay, now, here we're missing a couple of things. We're missing the FS module, of course. Let me import that. The page file type, which will import from a different file. Let's take that. I will copy both of these and go to types. I'll go outside of source. Actually, no, in source. I'll create the types folder in source. Let's create it here. So I'll go to types now and create I'll call it result types ts file because they're related to the results or the data fed to the model. Or I can call it page types as well. Yeah, let's do that. It's better. And I can export these two types from here and import them in where I need them. In this case, I'll import type page file. From types, page types. I like to have white space between my type imports, or have my type imports first and then my modules. And now my utils are good. Let me just change these double quotes to single. Here I won't touch much more. Just go back and see what else we need to take out. Here we don't need the fs function anymore. Of course, seed data will be in a different file in helpers. Again, this is a functional approach. And here we need to import. Let's transfer the imports. It will be easier. Seed data. Yeah. Here it is. I'll import read files and vault metadata from utils. What else do I need? I need the recursive character splitter. There we go. And finally, export default seed data. That's pretty good. Much better than what we had before. And let's import seed data from helpers. And that's essentially how I would structure it. You can see it at an API endpoint. This will be a RESTful API when we are done with it. So you can run this function in a controller at a certain endpoint, passing it the relevant data. Now, for now, I'll keep that function here and comment it out. Of course, in this order. We need to create a model because I'll structure this as a model. After all, it's a function class layer that interacts with a database. In this case, a vector database, but it doesn't really matter to me. So I'll call it a model, and it will be my context model. That's how I'll call it. So let's see, what should it have? I'll just transfer this logic essentially. I think I'll define the Chroma client in the main function and pass it, or pass the collection. Let me think. Do I need the Chroma client anywhere else? Yes, for seeding. So I'll probably create the client. Yeah, I'll create the client here and pass the collection to the model. So this essentially will happen in the model. Or I could just see it in the model. Yeah, that would be more appropriate. Let's have the client in the model. So this logic can be here somewhere. Here we'll have a client. So let's initialize it in the constructor for now. Yeah, change this to this client, delete, indent. Pretty much the same thing. I need to import Chroma client. This is a wrong import. I'll go back to index and copy these two imports, as I'll need them here now. In fact, I have double quotes here, so let's fix that. All right, and I need the collection as well. So I will have it right here. It will be an object of the class because I need my methods to access the collection. And I'll import the type. Okay. What else do we need to do? Well, we need to basically transfer this to a different function because it needs to be async. Init collection. Okay. And this will use this client, basically. And here we just call it. All right. Now, we also need, no, we can't call it here. We need to call it, we can't call it in the constructor because we want to await it wherever we call that, which will be the main function. We could have an async init function here that does this. We couldn't define a client in the constructor. No problem with that. Now, let me just change these double quotes because I hate them. And I have them at another place. It's because of LLM autocompletion, basically. Now, see data, we can run here. It can be a method, and it will just use the seed data helper with a collection. In fact, I don't really need that as a helper anymore. I can just transfer this logic to the actual model file. It will be more appropriate, as right now it's just a proxy function either way. And I can copy these imports, see which one of them are duplicated. Only this one. This is not necessary anymore. And we have to import this from helpers utils. But besides that, we can copy the rest of the method, I believe. Yeah, let's do that. Cut. And I'll paste it right here. And it needs this argument that is what? Collection. It doesn't need it anymore. We just need to fix that with, prefix that with this collection. And let's fix the indentation. Okay. And now I can remove this. A little bit of an aggressive refactoring, but it's coming out relatively clean. The context model needs to also support query. An async query function, which will accept a query string. And let's implement it. It's already implemented. We're just refactoring, really. Let me fix the indent here. Okay, we get results from this collection query, and we return results. That's pretty much it. Not much else is needed. We need to, of course, pass the query here. Yeah, and results should be a parameter. Let's we'll also set it to 5 by default if we don't want to pass it. Okay, this import is a necessary export default context model. And this is initialized how? We initialize it with init collection NASA missions. Sorry, what am I doing? This should be the collection name string, so that the model is somewhat reusable. Okay. Ideally, these settings should be in a config file also. So let's do that. We want the same functionality now. So we need to import context model from actually models. Yeah, context model. Create a new context model. Init collection, which will be NASA missions. And finally, query for whatever, 7 results. And output the results. And we should see a similar output than before, but a much cleaner architecture. Where am I? Go to the root and npm run start. We have a syntax error, which is expected. Undefined. This collection is undefined. I need to await init collection. Let's try again, and we get the same results. Of course, I can control the length of the response. Let's go with 4. It should be shorter. 4 chunks. Great. And this is a good start. We have a model. Now, of course, we need to also create a controller which which works with a RESTful API endpoint. It takes the context, receives some kind of query, passes it to the context model, receives the context, and interacts with an LLM to generate a response. And that's the next step we'll prepare before the RESTful API. And really, I'll use the OpenAI client for Node.js because it's probably the most you can use it with really any endpoint that supports an OpenAI compatible API, and that's most LLMs in the world. So it's very universal in that sense and easy to use. Of course, it's easy to use. It's just a client that does RESTful API requests. You can implement the same things with simple fetch calls or just HTTP requests in whatever programming language. This is just more convenient. That's all. And I install the package. We'll, of course, again work in the main function first to test, and then we will go ahead and abstract this in controllers. Now, OpenAI, we import it, we create a client. Let me comment out all of these for now about the context model. We create a client. So you need to pass an API key. This is the default process environment OpenAI API key. I have that environment variable on my development machine, so I don't even need to pass settings. To use OpenAI's actual API, you need to register on platform, and the APIs are paid, but they are very cheap for the small models. Let me show you the pricing. That would probably help. OpenAI API pricing. Of course, the models might change if you watch this video in the future, but at really any point, I believe, they have a smartest model that's a little bit more expensive at $2 per million tokens input and $8 output, which does support some caching. But if you use some of the smaller models like Nano and Mini, especially for testing and development, you really won't do anything more than a couple of cents. Like with the Nano model, I barely was able to do like a cent or 2 cents while testing. They're extremely cheap. Now for actual production usage, of course, you're using this for site search. So if you use a complex model and you have a lot of traffic and a lot of requests, you would get a bill that is quite large in some cases. In other cases, your traffic and the actual queries you receive might be so little that you barely pay anything with OpenAI's API. Of course, it depends on your use case, how much you have to spend, and the convenience. It's convenient, it's an API, it's fast, easy to use. But at the end, I will also show you how to implement this with an Ollama endpoint. Ollama essentially exposes the same OpenAI compatible API, but with a local model. And in many cases, to be fair, for search, if your site content is not that complex, a local model with only a couple billion of parameters can summarize content quite well in natural language. We don't need the smartest models for RAG all the time. Again, these things don't have a general answer. Everything depends on the content, what the matter is, the length of the context. Just it depends on your site and what results you want to achieve. But in some cases, you might be okay with a smaller model. And for the test, for these NASA missions, I'll use the smallest model from OpenAI, GPT 4.1 Nano, for just cost saving purposes. And it's fast. It's very fast. It's almost instant. And you just go to the platform and generate an API key from right here. And you can export it in the session and or have it in a GitHub secret or whatever. But I have it in my as an environment variable right here, so I can just create a client, and we will use that client. I'll call it OpenAI, and we'll use it. There are a couple of APIs. This is a new the responses API, which is not supported by Ollama at currently and other OpenAI compatible providers. It's a little bit simpler and better, but your chat completions API is supported by pretty much anything. So we will use that right now, because later we can just change the endpoint here in the client creation, and this will work with Ollama or any other endpoint as well. If you're watching this in the future, Ollama might support this endpoint as well. And really, there's no difference for our purposes in both endpoints. So whichever one you use, it's going to be pretty much the same thing. All right, so here's how this works. We have a chat completion, which we request. We specify a model. So let's specify a model right now. To do so, I'll go to the platform playground. I just want to copy the model name. It's like this. Let me see. Can I copy it from here? It would be much easier if they didn't make me do that. Okay, GPT 4.1 Nano is a very small model, but it's intelligent enough for the purpose. And then we pass messages, which are the prompts. And we have two prompts: developer, or in other words, a system prompt. If you know prompt engineering, you know what, and user prompt. This is an answer to the model asking the question, who am I? Basically, the prompt which specifies the system and the environment and what the point of the session is. And this is the actual single user prompt. We will do both, of course. Now, system prompt will be constant, and it will be right here. Let me define that. Here we go. Your helpful assistant that answers questions about NASA missions from the provided context. Great. That's actually a great system prompt. It's not that great of a system prompt. You can create a very good system prompt and define the rules and specific format of answering and constraints. This is great for testing purposes and for this demo. Now, the user prompt will be a little bit more complicated. But first, before doing that, let's just test the actual endpoint. I'll have a system prompt talk like a pirate for the test, and I'll just ask what are semicolons in JavaScript. And we walk the message, the first choice message content, which is exactly what we want. Let's start now. You should get the output from the model. Okay, we get the output. It's talking like a pirate and gives us some JavaScript, whatever. The JavaScript we asked it for. Let's go back and continue. So I wanted to add my system prompt here, and the user prompt will be a little bit more complicated. For now, let's define a static user prompt. This will be a RESTful API. We'll pass the user prompt from a user interface, an input, textual input that we send through HTTP. But now we'll hard code it, and this is our user prompt. What was the purpose of the able-to mission? That's actually a good prompt for our data, and Copilot inferred it correctly. But we don't just pass this prompt to the actual LLM because it doesn't have context. Like in this case, it might have some context about the able-to mission that we don't know because it's general knowledge as well. But in many cases, it won't. We need to pass the context. So we get this prompt and we enrich it. And to do that, we will first go to the context model. I'll just uncomment that right here. And we'll get the results from the vector database right here. And that is just a query. And the query to the vector database will be exactly that, the user prompts, because we want to find the most meaningful results related to it. And I'll get 5 results for now. Okay. And now that we have the results, they are in what format? Let me walk them so that we see. As we need to provide them into the user prompts so that the model can use them. I'll comment out the API call for now and then start logging the results from the vector database. So we have metadata, we don't care about that. They are not for the model, they are for the UI of the web application we're building later. So we care about these. They are in the result documents. And we have chunks here. In this case, it combines the chunks back together. So we will only have one chunk, but that's fine. And what we'll do is create an augmented user prompt. This is actually a great suggestion by Copilot. This is exactly what we want to do. An augmented user prompt, which provides context in this sort of HTML tag-like structure. This is understood by most models very well and used widely. And we map through results documents and open these chunk tags and provide each chunk. In this case, we only have one because of Chroma, but depending on the vector database, you might have row chunks here. And then we provide the user prompt here in question and ask the model, answer the question based on the provided context chunks. This is enough for a RAG. This is exactly what you want. And this is what we pass to the LLM. We provide context from the site, a question, and a prompt to answer it, given the provided context. The last part, asking the model what exactly it should do, is important because it shouldn't get confused that it should. The question might be confusing sometimes. You need to ground it in the sense that it should answer based on the provided context, although you're already grounding it with the system prompt as well. But here we're aiming for accuracy as well, not to avoid any hallucinations and wrong answers. And depending on the matter, that might happen. So you might need to ground it even further and ask it to only use the context and not answer with any other knowledge. But in this case, that's not necessary at all. And at the end, we send OpenAI the augmented user prompts. OpenAI or the LLM. And let's see the answer. So currently we have a hard-coded prompt. What was the purpose of the Able2 mission? And let's query it and see what will happen. And we get the returned results. Just for reference, I want to show you the prompt we're sending, because the prompt will contain that information. If I start again, this is the prompt and this is the answer. We get the same answer pretty much. And this is what we have. First ever launch to the moon. Humanity's first attempt to send a spacecraft. And here we'll have some sentence that also names that, yeah, never reached the moon, but did return data on the near Earth environment. So it analyzed this, which is admittedly not very readable, just page content, a mess. And it answered our question based on the context. So yeah, this is sort of generally available information. The model might know something about it, but even if it isn't, this is the method, the way you would implement RAG for site search in that context to get meaningful answers. Now, let's go back and make this scalable, make this actually work with a website. So I remove the console logs and abstract this away further. This needs to be a RESTful endpoint. For that, you can use whatever server you want. For simplicity, to just be fast, and this is a proof of concept, I'll just use Fastify for really no reason at all. Just something I have used, one of the many RESTful API frameworks. This is the framework for REST, and the HTTP server infrastructure is not important. We'll have a single endpoint, so it doesn't matter that much. I will go to getting started and see how I can set up Fastify. So we need to install it, of course. Let's do that. Quite straightforward. We import it just like with our other models. Let me just add a semi column. And here we initialize the Fastify instance. Now I have the model initialization. The OpenAI client won't be here at all. In fact, before continuing with Fastify, the OpenAI client will be something entirely different, and I will abstract it away in a different file. I want it to be a different class, so I'll create an LLM client class, I guess, or just OpenAI client. It doesn't need to be that abstract. And I will copy that logic right here. Cut it and paste it here. And of course, here we'll have a constructor. Move that right here. I'll save this as an instance. Okay. Let's import OpenAI here. And really, the system prompt, there are multiple ways to handle this. The most scalable solution probably, which is not necessary in this case as I have a one-line prompt, is to create a prompts folder and save it as a textual file, markdown file, whatever, markdown file. In this case, it will stay a constant and I'll put it up top because it's a one-sentence system prompt. As I said, you can figure out how you want to handle it depending on the complexity. I'll have it all uppercase because it's a constant at the top of the file, really. The user prompt will not be a constant at all. And this logic will not be here at all. So I'll cut it, save, and take it back to the main function. Later we'll move it away to the actual controller. But the completion logic will be. And I would like to basically create a method here to respond. Should be async. I can just call it complete because it uses the completion endpoint. So that's sort of common sense, I guess. Here we have a prompt. And we don't really need much more. The content will be grounded by the system prompt. And we'll send the past prompt. Again, I'll define the model as a constant here. But you could have it as a config file. Depending on the scale of the project, you can make these decisions for architecture. This is a general suggestion from me, but it would really depend on what this is plugged into, what architecture, what RESTful model, or what server you're building. This is just one possibility. And of course, we need to change this to this OpenAI, but everything else is fine and exported by default. A simple object-oriented approach, nothing special, but it should be fine. Oh, and of course, just return the message content. That's what we care about in reality. And that should be fine. Now let's go back to index and continue building the actual Fastify thing. This I'll comment out and move away from the main function for now. We need it for the controller, but oops. But we won't need it right now. Okay. So where were we? we created Fastify. This is how you declare a route. Let's declare a route to test if Fastify is integrated. And then listen. Finally. Okay, remove some unnecessary comments. So we want the Wogger. That's fine. Let me remove OpenAI import. As I mentioned, we want the Wogger. This get function is just for testing right now. Let's keep port 3000. You would want usually a process environment variable here. And 3000 as a fallback. What's the issue now? String core number. Yeah, parse int of that. What's the problem now? Okay, so it should be like this. I'll do that for readability. But again, as I mentioned, that's not that important right now. I'll use 3000. Error address, I don't need address. Just go forward. And what do we have here? Syntax error. Yeah, that get function will get removed soon, so I won't fix that error. Let's just start now and test the Fastify server. We have a Wogger. If I go to localhost 3000, I should get hello world. And I do. Here you can see. Perfect. Let's close that. Now we'll remove that until we immediately create a controller. And that's done through plugins. Let's search. Just like you have a router in Express, here we have a plugin. And you can define a custom plugin, which is just a module, just a function that you export. Let's do that. So I'll create a controllers folder. Okay. I can call it the actual controller, whatever. I'll call it search. Let's create. So it should be just a function. I'm using ES modules. So let me just rewrite that a bit. Search controller is equal to a function. I believe, oh, it's a callback, so not an async function even. And export default search. Okay. Now we should add the types. Let's ask Avanti. Should I tell it I use Fastify? Okay, let's do so. Although the first parameter is called Fastify, it should infer it. Okay, can I import Fastify instance, reply, and request? Okay. I mean, these I don't use for now, and I can say import type here. All right. And here we call done, and here we have the Fastify instance, and we can call whatever. I have an error right now. Handler, yeah, that's fine. So I would want a single post endpoint to the root. Here we have request, reply. I don't even need to import these. It can infer the types. Yeah. And if I go here to the getting started guide, I can see how I can do a post request. It's very simple. Let me go back to the previous example. Request body. I have a request body. And here I will just have query in the request body. Wait, as string. Great. That's awesome. And if we don't have a query, return 400 and an error message. I'll fix the quotes real quick. I probably should start using double quotes because every single autocomplete just returns double quotes all the time. I don't like them that much, but it's just inconvenient to always change them. Okay, and here we have some suggestion that's a little bit, yeah, I don't think we'll follow that. Although, let me see. It's actually good. It caught onto it. It queries our context model, although that's not under Fastify. Yeah, that's good. We can get that. Let's get the context model here. That's the first step. The context model will not be in main, or we can pass it to the controller, but yeah, no point. I'm trying to think about the best architecture here in terms of we could pass it like this indeed. Context model like it suggested, but we need to extend the type. That's not necessary. As we have a single controller, I have absolutely no problem using a fully layered architecture and doing that here. There's no problem having that in the controller in this case. And let's do it right here. Okay. Import context model. Now this needs to be async though. Can it be async? I do believe so. I don't think there's a problem. So let's see. What do we have here? End results in query text is not assignable to type string. Yeah, absolutely. It just got the wrong thing. Here I need to say query. And the number of results, which should be something like, let's say 7. And here we do the augmented prompt, which should probably not happen here in a more scalable solution. You should have a different function that does this so that you can test it as well, prompt generation. But in this case, at this scale, single endpoint, single site search, it's okay to be here, to be fair. And I'll just copy. Wait, what do I need to copy? I have the prompts. I don't have anything to copy. I need to import my OpenAI client, initialize it here. Save. I'll call it OpenAI, just OpenAI for simplicity. And I can just say OpenAI complete augmented prompt. Now that is, of course, an async function, so I will have result await. And finally, just send response. And response, this will be called response because it's better. And in all cases where we have errors, just return internal server error. That error handling is sufficient for this case. And we go with done. Now let's test that. Here we have an unused parameter. I can just do this, I think. Okay. And let's register the controller, the plugin. We can do so by importing it. How was it called? Search controller? Yes. And after, where should we register it? Let me see. Plugins. I believe before. Okay. We can register it right here. And I can say register. It's a function. like this, and remove the options because I don't need options. And now my endpoint should be available. I will remove this right here and test it. Let's first start the server, make sure everything builds correctly and I can reach the endpoint. Let me see. We have an error somewhere. Async plugin should not mix async and callback style. Okay. Let's see how to use an async plugin. Wait. Okay. Fine. Yeah. Let me just go back to the terminal. I believe I should just await the registration here and go to the creation of the plugin. Here we don't need done in that case. We just need to remove that. And that should be fine. I'm guessing. Okay. Let's test. I can test using Insomnia or just some client before making some front end for search. Really, any API client is fine. Here I did a similar test before. This time the endpoint is not even search, but let's actually test that, change that. The endpoint, I want it to be. Now, this is a good structure. First of all, everything under API on that domain where you're running the server. V1 ensures you have ability to do a breaking change by changing this to V2 and then search. You can, of course, specify an endpoint for the whole controller as well, I believe, which is better in some cases. So let's do API V1 search. I need to restart the server here. And the body will be, that's actually a good query. What is the first spacecraft launched to the moon? And we should get a rack result. Great. Works flawlessly. Let's just walk here. Where should we walk? Maybe right here, the augmented prompt. Just so that we have visibility what's happening when we make the request, I want to demonstrate. I'll do the same query again. And here it is, the augmented prompt. We have context. It's quite a lot, actually. We can probably lower it to 5 for this specific data. I don't think we need such a big context retrieval. Yeah. And then we have the question and we get the response right here. And as you can see, with this RESTful API, we can now successfully build a front end. But before we do that, let's first talk about an alternative model. For now, we've been using the OpenAI endpoint. In fact, I can actually check how much tokens we've used, although we've used so little. And this is the nano model. But we already have some usage probably. Yeah, I have like, I don't know, 3 cents for the day. Considering I did like a lot of tests before that, today I used the nano model quite a lot. But this is also the dumbest, the least smart and fastest model they have. So you might not be able to use it in many cases. Still, let's run Ollama. Ollama is quite simple. It's a single binary solution to running local LLM models. And you just download it for any platform, macOS, Linux, Windows. On any platform, it's quite simple to run. You can just run it as a service. On Mac, you have this app right here that you can also start on startup. It will start and run in the background pretty much. And then you have models. Now, you will be watching this in the future where you hopefully have a lot of better models. available open source models. Open source models are not bad at all. There are amazing open source models which you can run on relatively affordable hardware that are very smart and capable. At this point, some of the best open source models are DeepSeek, Gemma, and Quen. And for cases like RAG conversation, I would prefer Gemma as a non-thinking model because it will be faster. Gemma is Google's open source model, and this is a very well-powered laptop PC for development, so I'll be using the 1 billion parameter model. So this is a very small model, and still you will see it will be able to summarize content correctly to give us good results. So I'll use that. Let me show you how. After you have Ollama, you just run in the terminal, run the model name. Let's test it out. I'll quit that. I already have Gemma 3.1 billion, but if you run it the first time, it will download the model weights, which is just a single file of like a couple of gigabytes usually. And when you run it, you can ask a question. There we go. And we get the response. As this is a 1 billion parameter model, it's quite fast. And now to use the OpenAI compatible API, I'll just Google Ollama OpenAI endpoints. And Ollama has OpenAI compatibility. Here we go. You can use it with any model. And here we have the OpenAI JavaScript library, which we actually use. The only thing you need to do is set the base URL to the Ollama hosted endpoint and any API key. So this is all we need to do to switch to a local model. Let's do it. I'll just go right here to the OpenAI client, go to its definition. Okay, that was wrong. OpenAI client, go to its definition, and here where I define the new OpenAI client, I'll add this config. That is just base URL and API key. And they'll be the same for me because I'm running it locally. And the API key is just a string. You don't need to input anything. It won't check it, the Ollama instance. Now, let's see. Can we close that? We can close that successfully and just test again. I'll do the same test with Insomnia and run the same query. In fact, that's a good opportunity to see the difference in the models because the local one is just a 1 billion parameter model. We get the basic information here with GPT 4.1 Nano. Let's run the same search again with the local model. We have an error. Of course, the server is not running. Let's start it. Okay, and send the request. We have internal server error. Let's see the error. We have model GPT 4.1 Nano not found, of course. We haven't configured Ollama correctly. Now we're still prompting for the GPT 4.1 Nano model, and we don't have that. We have, let me close that, Ollama list, Gemma 3, 1 billion. Let's copy its name so that we don't make a mistake and paste it right here. All right. And now let's restart the server and try again. This time, should be able to use Ollama. There we go. As you can see, the answer was a lot shorter and not that good, but it is a correct answer and it gave us the response. We can ask something different, like what if we ask for the purpose of the Able 1 mission, it might give us more details. Okay, yeah, concise answers, not the smartest model in the world, but it's totally local, running on relatively like very, very cheap hardware. And that's quite good, let's be honest. Now that we've talked about the local option, keep in mind you don't need to even use Ollama. you can use many other API, OpenAI compatible APIs like OpenRouter or any other LLM that exposes an OpenAI API endpoint with the same code and architecture I showed you today. That's the great thing about the OpenAI client. It's widely adopted, its API format, and we can use with just a simple config change, 1 or 2 lines of strings, we can change the entire model provider. Okay, let's build some front end just for completeness sake to see how we can complete this really. Of course, usually, if you're building this for your site, you would integrate it with search or create a separate view for it, or maybe a floating widget here that you're able to query with an LLM. There are some good use cases you can check out, like the Rive app documentation has integrated LLM in their documentation. Here we go, Ask AI, and we have an entire assistant sidebar. So how can I animate text? It should answer using a similar approach most likely, or a ready-made solution. I won't waste time waiting for it. I'll just go ahead. And I just wanted to mention you'd usually integrate this into your site. As this is not my site and I'm using test data from NASA, I will just build another front end just to demonstrate how it would work simply. I'll use Mantine. Let's just pin up a Vite app, Vite React app with Mantine for the UI for simplicity and speed. Let's go back to Mantine. Let's go back and go to the Getting Started guide. And we have a Vite min template. Let's use that template. Okay. Let's clone this. So now we are going to a totally different project. We had the Crow project and the Crow software in Python. We had the rack search. That is essentially an API, RESTful API that's still running right here. Now keep it running. And we will now make a front end for our search. Let's copy that Vite template. I'll rename it to NASA search. Okay, install. Run npm install, and then we'll see what kind of files we have. Clean it up a bit so that we can start. We'll build a search bar and show the results. That should be sufficient. I will open new vim, of course, and let's see what we have. A yarn work file can be deleted, please. We have a Vite config, that's fine, just fine. Package JSON seems to be all right. Yeah, everything is pretty standard here. I remove the README, remove the yarn.rc file. In public, we have some fav icon. Just leave it. It's fine. Okay. And it's quite minimal, as you can see. Team, put your machine Mantine team over right here. We won't touch that for now. Here we just have the HTML root, and again the quotes, as always. Okay, app tsx. This is where the Mantine provider is. I have my app. Let's go to a couple of lines here, and we can build most of the app here. We'll just have a single user interface. I'll just change my quotes again. Yeah, that's good. I mean, I don't need a theme file. I use the default theme for this demo. Let me also remove the theme file from here. And in Mantine, we can build out a simple user interface quickly with just a few components. I need an input. There we go. Just some text input from Mantine core. Let's import that. Let's copy the sample input right here, I think. Okay. I will change the label, of course, to search. Okay, let's put a description. AI assisted search. LLM augmented. All right, that's good. This, we need a button, a form. This will be a form essentially, which you submit for the demo. Really, you have a lot of flexibility as to what kind of UI you want to build and integrate it. You can do anything, let's be honest. It's just a RESTful API, so you have the freedom to integrate it anywhere. And here we'll use a button that will have a submit type, and it will just say search. Let's put that in a flex container with some gap between the elements. I'll import flex right here and indent that properly. And now we need a stack because we want to put the results here in a cart. Just some Mantine, that's a box essentially. And I'll import that as well. Let's go 11 down, and we need to import stack as well. Stack is just the vertical layout, and I'll have gap large here. Let's fix the indentation, and here in cart we'll have results or a folder, small folder, let's say. Okay, let's see what we've built. Actually, let's also import the center component that justifies content at the center and just center everything. That reminds me of the center tag in HTML back in the day. Okay, and let's create a new terminal session. Go to that Mantine folder, which is NASA search front-end server, front-end project folder, sorry, and run npm run dev. And let's see what we built blindly. Not that bad, to be honest. We need a little bit of a width here. First of all, this will have width of 100%, let's say. And this can have a width of something fixed like 160. So the button is a little bit larger usually. Let me just find my browser. Where is it? Right here. Okay. Okay. The entire stack can have some fixed width. Something like 680, let's say. It's too big. 480, more like. Okay. Here, the justification of the button should be at the bottom. So align flex end, the alignment, not justification in this case, as it's a row. And that's okay. The cart should be bordered. That looks good. And we're getting much better results. Here in cart, I'll have another center because I want the folder to be centered and the results to be left aligned. Okay, these won't show up together. And finally, let's have a height on the center tag so that the entire UI is centered. So this is what we'll build for now. I will now add state and interactivity to it. So let's do that. I'll import use state from React, and you need two state variables, isWolding and results. which will not be string or no, it will be just string. An empty string is fine as the no state. And we need to handle submit on the form. On submit, we'll handle it right here in a function. And we will have an event. That will be a React form event, I believe. HTML form elements. I think that's the correct type. And for now, we'll prevent defaults so that it doesn't redirect. We'll set this loading to true in the beginning. We'll get the form data. We'll convert the form data to object. Maybe JSON data. I don't need JSON stringify. Just real JSON. And what else? Here we have an error. Declare burn never read. And let's just log it for now. In order to get the form data, we need to name the field. And I'll name it query, because that's what I need to send to the REST request. And here, let's fix that and show these conditionally. If it's loading, we'll show this loader, of course, else nothing. And if it's not loading and we have results, we'll show results. Otherwise, no. That should be fine. Not results, but result. It's a string, so it can be shown here. And we don't use set result yet, but we need to do the API request first. Let's first see the UI. So we shouldn't show that box if we don't have a result or it's not loading. So if it's loading or result, then show the entire thing. Otherwise, nothing, of course. And let's go and indent that. Okay, that's better. Now we make a request. In the console, we should have the correct form data. There we go. Query and our query right here. And let's now do an API request. Quite simple. This is an async function. So we can do request fetch. Now we are working in this case with a local API. Of course, at port 3000, the endpoint is API v1 search, right? Absolutely. And we need to pass options. Let's create a separate variable for that. And this is pretty much what I want. Method post, application JSON content type, and stringify the data. After you await the fetch, we check if it's okay. If it isn't, set is loading to false. Set the result to error. Yeah, that's fine for error handling right now. Then we parse the JSON. We can set this loading to false and show the result. Okay. And this entire thing, of course, can be wrapped in, should be wrapped in some kind of error handling right here. We can catch the error, set the result to error in case something happens. We can remove that and do that in a finally block. To remove the loader in a finally block so that we make sure whatever happens here, we always set is loading to false. And we can remove that code repetition. If request is not okay, I can just throw here. Mm, like this and not return. This can become a one-liner. It's a little bit more concise, less repetition. And that's pretty much what we need to do the API call. It should work except the course config. We should get a course error right now. But let's check. What is the... first, before I check, I would like to quit that and go back to my OpenAI config because the model is better and I want to do tests with it. Let me just find my OpenAI, what was it, client. And I just need to remove these two. Actually, can I go back? No, I can't easily go back. Just remove these and go back to the model. Let me find my browser to find out how the model was called exactly. GPT 4.1 Nano. I'll copy it again to avoid any typos. It's just practice. I make a lot of typos otherwise. And now we should be back to the OpenAI model API. And actually, let me see, where was I? Yeah, I needed to set up some course. So this needs to happen right here. Let's go to the browser and do a search for Fastify course. It's a plugin that you just install and initialize to enable some course rules. Let me go back to the rack search package and install Fastify course. And let me see how it's used. Import it and register it. It doesn't get simpler than that. How do we register it? With a wait. Okay. And I believe one of the options is origin. And for this proof of concept, I will allow everything. You shouldn't. You should allow only the origins which you want. Your services that are going to be using this API, of course. And let's go ahead and start the rack service, the search service, and then I'll create another terminal and start the front end again because I had to quit that. And now, if I go back to the front end in the browser, I should be able to actually use it. Let me see. 5173 was my Vite app. Okay, let's test. What was the purpose? Let's see, what was the first spacecraft mission to the moon? It should be enough for the model to understand. Let's see what we got. We didn't get the actual result. Let's troubleshoot this. We probably didn't get result exactly. Let's see what kind of response we got. Maybe it's called differently and not result. What was it? It's response. So I should use response right here. There you go. I think it will hot reload, so let's try again. There we go. The first spacecraft sent to the moon was Ava 1. I like how concisely it answers, even without me prompting it to be very concise. I noticed that small models, nano models, and models that are optimized for efficiency and speed are usually very concise, and I actually like that. We can ask other questions, like what was the purpose of Able 2? Let's submit that. There we go. We don't have information about Able 2. You see, that's great because we tried to ask it a question outside of the provided context and it doesn't answer. Um, and that's great. That's exactly what we want. Let's ask what is the purpose of Able 1 then? First ever launch to the moon and humanity's first attempt to send a spacecraft beyond Earth orbit. Okay. What are some NASA medical oriented missions? Let's see. There were some, so it could answer. 3D tissue chips. So quite awesome. We get this data from mission nasa.gov/missions, and this could be data from your side. That's the point. We augment it, we feed it to we got this data, crawled it with Crow for AI, fed it into a vector database by chunking it and embedding it, and we retrieve it and enrich the context of an LLM. And this is very powerful, especially for, in my opinion, something like a documentation website or just a place where you have a lot of knowledge and people would naturally search for context within it. And if the knowledge is not widely known or the site is private or it's just niche and it's not indexed by large language models already and fed to them as knowledge, this is a great way to provide users with a smart search engine that also provides human language results, basically. And yeah, I just fed it some junk. But if you ask specific questions, it will be helpful. Yeah, that's great. I really like it. Okay, I did cut the video here. It's actually a different day now. I already filmed the previous part, but I noticed that I forgot something very important here, which I want to add to the implementation. So here's the state we were at when I finished the search. And it's, we've built the rack, we can ask a question, but it sort of isn't a search, more like a chat LLM assistant because we don't return the URLs on the front end, the URLs from the context, which would be a requirement for me if I was to call this an actual search engine. And that's the entire reason why we have this metadata here. So if you remember, in developer, if I go to the folder of the Crow, we do have this metadata JSON file where we identified each result with let it just load, each result with a URL. And we passed this result to Chroma, to the vector database. Let me go to the actual database seeding process. So we did pass this metadata items to Chroma. And in it, we have the URL for each chunk. So we should have that right here in the controller. When we send the response, we get the context model result, which is the vector database result, and you augment it with documents. In the augmented user prompts for each search, if I open a simple process, let me see, is that context. But we also have the URL here and we can pass it. Right now, we just return the response in the JSON object. Let's see first what the actual metadata contains. It's an array. I will output results metadata. I believe it was metadata. Let's see if that is correct. I'll restart and just do a quick query here. The same question essentially. And here are the metadatas, chunks and URLs. And the reality is we don't care about the chunks and their relation because here we just pass them to the LLM and we get a summarized natural language response. But I want to list the URLs from which this response comes under the actual natural language response. So I'll send an array of URLs. The thing is, these might repeat, so I want them to be unique. And I can implement that. So this is an array. Is it an array of arrays actually? it is. So it's an array of arrays, and then we have objects where we have chunk index and URL. And we can process that. I would say let's just iterate through it. Okay, so iterate twice. And if we have a URL, I would say let's have a string array right here and push to it. I'll remove that and just now the thing is that probably shouldn't be an array because I want unique URLs, and the best way to do that would be to just create a new map or a set. Actually a set, I believe. The set is the correct data structure for this. Let me just look it up. JavaScript set. Lets you store unique values of any type. Okay, that's exactly what we want. And we'll create a new set and we can add to it. What do we have here as an error? Metadata is possibly no. So I would just check if metadata and metadata URL, that is enough. Okay, and the thing is, here we just have to pass response to the front end and URLs. And URLs would be array from results. We convert the results from a set to an array so that it's the most basic data structure. And that's all I really need to do here in the backend service. Let's restart the backend service, the API, and I'll go to the front end to implement the actual list. I will, so this is my, let me see, I don't believe I need that debug session. Okay. I'll go to the app component, and here's where we receive the results. I also walk the response. I'll just set results and also have a state management for URLs. So that we can be a string array. I'll remove this. Actually, you know what? Let's leave them for now so that we can test the actual UI. I'll do that. Here we have an error. It's not used. Okay, that's absolutely fine. And here we'll just have set URLs to response URLs or to nothing. All right, let's out them. We have these sample URLs here to see how they would look. And I want them under the response. So right here. Let's just create a UL for now. And that UL will be, there we go. Let's see what Copilot would recommend. It's actually the correct recommendation of what I wanted. We map the URLs, and this entire UL will appear when if URL's length is more than 0. Yeah, in that case, we'll show the entire UL. Otherwise, nothing. And let me see. I think I lost my... Okay. Here we need to encompass this in an element, because this is React, of course, in a fragment. And let's see, maybe we have something unclosed here. We do, absolutely. We have a map function and another set of brackets that we need. Yeah, that's it. Let me fix the indentation now because it got messy. And that should be fine. Why is my indentation still messed up like this? Let me check. Here we have URLs, the fragment. The UL is wrongly indented. Okay. And I don't know if we need the headline, to be fair. I'll remove that at all. Let's just list the URLs for now. It's quite obvious. Okay, let's do a test search. What was the purpose of Able 1? Yeah, we get the URLs immediately because they're hard-coded now. Oh, we actually got the real ones after that. And we just list them right now. Of course, we can use something from Mantine to make them look a little bit nicer. It's not necessary at all, but why not? I'll go to components and look for list. And we have basic list item. So I'll just add a divider here and divider to divide the items, make them a little bit smaller, and use the Mantine list component. That should be enough. I will also remove the sample data, leave an empty array in this case. And here we need a divider. Like this. I again need to add the fragment because now we have 2 elements. Okay, fix the indentation. Let's check that part out. Okay, that's good. I'll add some margin top to it. And besides that, let's see how to use the Mantine list component. There it is. List and list item. Ordered, unordered, and size. So we'll go small, unordered. And I'll quote that right here. And here we need to change that to list item. And I can also use the Mantine anchor tag to get the proper styling. It's the same API. So I can just change that to the anchor component. And let's import these two. List anchor. That should be fine. Okay, let's test now. Now we get proper results. I would say the anchor size is incorrect. And we need some more spacing. I'll change that margin to margin. Is that the y-axis? Yes, it is, of course. My. Okay, that's much better. And we have the actual search results together with a natural language response. Now we can call this a search. I wanted to add that functionality because we passed the metadata right here in the object, actually the URLs, exactly for that reason. So we can summarize the context chunks, but also pass to the user the actual URLs because he would be interested in the full textual content. That's probably why he's searching for an answer. And he sees able 1 and he's able to explore it in depth on the actual page URL where that matters. Or if his question is more exploratory, he can actually find something and he'll be able to go deeper. The thing I would like to mention now is where you can improve quality, because at this point, obviously this data is quite simple. It's white knowledge and it's very specific missions, small chunks of knowledge. We get good results, but we ask simple questions as well, and the data is not that complex. In some cases, at this stage, you might get answers which you're not satisfied with. And you can try a couple of things. So the first thing you can try, and you should start from it, is the data. Analyze it, see what data you extracted. Now, I know you might be working with a very large site, or like at this stage, I'm basically pulling 35 pages. With this scale, if you have like 30 pages, you can go through each file and just edit the results manually to just adjust them and make sure the file is very carefully. Uh, just the file is very valuable, concise, and has only information, dense information, which would be best for the model. But in some cases, I understand you might be working with 10,000 pages that change daily. In that case, make sure that the crawler is configured very well. and you extract only very specific data. Uh, it's extremely important. Here we're talking about working with a large language model, and we need dense quality data to feed it as context. And the quality of the response will be directly related to that. As they say, junk in, junk out. This is software after all. We need very good data. So you could start from that. If you can improve the quality of the data, you will improve the quality of the responses for sure. The next stage, if you're confident the data is in a good shape and that it's not the cause for the issues you're having, um, or you cannot improve it anymore in any way, the next stage would be to improve the embeddings. And here in the context model where we create the embeddings and we see the data, as I mentioned, we can first change the chunk size and chunk overlap. That's important. I would advise you to check out the chunk sizes with console walk. You can do that, or just output them, query something and output the chunk sizes and check if they make sense. Um, like as a human being, you're good at analyzing text, better than a large language model, and you can judge how much sense does a chunk make by itself given the nature of my content. If it doesn't make much sense, you should lower the chunk, probably make it larger or smaller. Usually, if the chunk size is too small to make any sense, you have to make the chunk size bigger, generally speaking. If the content, if the chunk size is large and it, depending on the content, encompasses multiple meaningful phrases, and you think you can make it smaller and more concise, lower the chunk size. You can judge it yourself before even doing anything more, but you can also adjust these two parameters sort of uh, as you are testing the model end to end. Just open your browser, chat with it, or even better yet, be more scientific about it. Craft something like 50, 100 prompts, whatever, how many you can, and record the responses as you adjust the chunk size and chunk overlap. The overlap, you can be a little bit more systematic about it and go with something like 20% of the chunk size. But the chunk size is more important. So adjust the chunk size and check the responses. Record them in a spreadsheet or whatever, and just this way you can find a sweet spot for your data. The other thing you can do is, as I mentioned, start from the data. We now go to the embeddings, chunks. If after having good chunks, you still are not satisfied with the quality of the results, you can go with the more sophisticated embeddings model. As I mentioned, the meaning of these chunks of text in the vector database is encompassed using just a couple of numbers in vector space. And these numbers are generated by an embeddings model, which we currently use the default model used by Chroma, but you can get a very sophisticated model that can probably generate better embeddings, and you get better meaning, but just better meanings in vector space from a better embeddings model, which can improve wrong retrieval. This is another step you can make to make sure your rack retrieval is better. And you can see if that is your problem if your chunks are of good size, but when you make a query, you don't get the most relevant results. In that case, you probably need to change the embeddings model to something more sophisticated. And you can use the OpenAI you can use the OpenAI API for that as well. They have an embeddings model. Google has one as well. Pretty much every LLM frontier web has an embeddings model as well, which will be better than what we use right now, the free one. But don't. It depends on your content. This default model for embeddings might be sufficient in many cases, like this case right here. So after you do all of these, and make sure the data and the retrieval works correctly and you've fine-tuned everything as much as you can. Only then will I turn towards tuning the model. Because the model is not probably, is the most expensive computation, no matter if you do it on locally or if you prompt an API. It's an expensive computation. You could literally pay for it if you use the OpenAI API. So switching to a smarter model should be the last step after you make sure the data and the retrieval work great. If the context is amazing and you can see it in the prompt and the results are not good, probably the matter you're trying to summarize or expand with a large language model, conversational model, is just too complicated for the actual understanding and reasoning capabilities of the model. In that case, you probably need to go to a smarter model, something more sophisticated and more expensive or more computationally intensive. Usually, both are related. But that is uh, not always the case in my experience. Small models can summarize, because here we're basically just summarizing context. Very small models can summarize context really well. And you need to really have complicated material here to need a complicated large model. So this is what I wanted to share today. We built a RAG-powered LLM site search, and we even built some front end for it. I hope this is useful. I think it would be useful for many websites, especially dense information websites like documentations or sites where users utilize search a lot. You can also find some ready-made services for this. There are some available, although they have associated costs with them. With this, I'll wrap today's video. If you enjoy the content, feel free to subscribe to get notified when I release another one of these videos. As always, take care.